It's only June 2025, and it already feels like we've lived through 5 years of AI progress in just 6 months. Every week there is a new model, a new capability, or a new tool that reshapes what's possible. Google released Gemini 2.5 Pro and Flash. They also introduced powerful new generative models Veo 3 and Imagen 4. OpenAI launched GPT-5 Turbo, delivering faster, more contextual, and more human-like conversations. Microsoft introduced 2 Copilot agents to support deeper reasoning and analysis. DeepSeek surprised us with high-performing models that can easily compete with OpenAI and Google in reasoning and code generation. And that's not far the end of the year. These innovations are redefining what's possible. Features that seemed impossible a few months ago are now trivial to implement. Thanks to these tools, we can build both smarter applications and build applications smarter with a rise of vibe coding. Adding intelligence to our mobile applications is more accessible than ever before. Unfortunately, if you want to borrow the power of big AI for your mobile apps, there is a price to pay. Large language models rely on heavy cloud infrastructure and simply cannot run on local devices, at least not yet. Since they're hosted in the cloud, every interaction requires a network request. This introduces latency. While a fast connection can hide it, users with poor connectivity may have a much worse user experience. And of course, apps that require constant network access just cannot work offline. As your app grows, so do your costs, quickly and exponentially. And let's not forget the privacy concerns. You never know how the data of your users will actually be used. You cannot be 100% sure whether personal information of your users will be used to train new generation of AI models and what kind of data leakage you may expect in the future. All these concerns leads us to an important question. Can we actually run AI locally on device? Because it looks like that would deal with majority of concerns, may significantly improve user experience, lower the maintenance costs, and eliminate any security concerns. Let's find out. But before we begin, let me introduce myself. My name is Oleksandr Leushchenko. I am a Google developer expert in Dart and Flutter. Also, I am an engineering leader coaching high-impact teams. I currently work as an engineering manager at a UK fintech company called Tide. I am passionate about augmented reality, mobile applications development, and machine learning. And in this talk, I will combine 2 of those passions. First, let's clarify one thing. Artificial intelligence is not equal to large language models. LLMs are just one type of model. The foundation of AI is machine learning, and many powerful ML models have nothing to do with language. Narrowing the scope, you may integrate AI into mobile applications to solve specific tasks, which would eventually lead to smaller models that would require less performant devices and that eventually make them suitable for all smartphones. There are many classic machine learning use cases that have been running on devices for many years. Like, for example, object detection, when you need to identify objects in a photo, or image classification, when you need to describe what's captured on an image, or image segmentation, when you need to highlight some areas on an image, or gesture recognition that's especially valuable for accessibility in devices and mobile apps, or text classification that would allow to adjust the user experience based on user input. And of course, there are many more use cases for machine learning. Actually, you can build anything. Any kind of AI feature is possible with ML techniques. However, unfortunately, that's not so easy. Model training is a craft in itself. It's not as complex as getting a PhD, but it's far beyond prompt engineering. It's more like programming in assembly. Powerful, but too low level for average mortals. At a high level, you may think of a model as a combination of some algorithm and data. The good news is that most of the algorithms that you might want to use in your applications were already invented decades ago. The bad news is that to make these algorithms useful, you need good data. And the main problem is that most likely you don't have good data to train a model. However, everything is not lost. Thanks to the community, you often don't need to train a model from scratch. As I said, running machine learning on device can solve many problems. There will be no network latency, no usage cost, no privacy risks. And the real question is how to actually put a machine learning model into your application. Well, you may guess that someone smart has already created a framework for that. In fact, there are many frameworks for you to choose from. I would recommend trying LiteRT first, formerly known as TensorFlow Lite. Why LiteRT? Well, it's baked by Google and has a really large community. It's cross-platform, which makes it a solid choice for your Flutter applications. While it's platform agnostic, it's highly optimized for mobile performance via a mechanism of delegates. And it supports model conversion from popular frameworks like TensorFlow, PyTorch, and JAX. If you go with LiteRT, there is a chance that you would not need to create your own model. You may open Hugging Face or Kaggle and pick a model provided by the community that will solve the problem you want to solve in your app. I used AI in my applications before it became mainstream, and I'd love to share a few use cases from my career. Of course, I cannot show models that I actually used in my applications, but we will take some free alternatives and build something useful with them. With the release of iOS 7, Apple changed the design paradigm. They moved from skeuomorphism into a flat, minimalistic design. Many years ago, I was working on a simple diary application that allowed users to take daily notes. The interesting feature of that application was the UI that used Apple's new design language and adapted itself, like changed colors and overall style based on the mood of the message that the user enters. Let's build a similar functionality for a really simplistic diary application using sentiment analysis with a simple text classification model. Let me show you the application first. As you may see, it's a simple single-page application sentiment diary with a single button. When I tap this button, it asks me how was my day. Today was a superb day. I was in a park with my friends and then we had a party. Great, you may see that now our diary has one entry. It's marked with green and its sentiment is 0.6. Let's add another entry, something like today was the worst day possible. I don't even want to write about it. As you may see, now it's red and the sentiment score is quite low. Let me enter one more diary entry here, something like today was okay. You may see that sentiment score is 0.5 and the today was okay entry has gray background, which means it's neutral. Let me show you the implementation now. And let's start with pubspec.yaml file. It has a single dependency tflight Flutter, which stands for TensorFlow Lite, which is the former name of LiteRT framework. This project has assets. Let me show you these two files here. The first one is a binary file of the text classification model, and the second one is a special file with vocabulary for this model. It has a map of strings and integers, and each word in this vocabulary has a corresponding number associated with it. We will see how this vocabulary is used in a moment, but first let me quickly show you the main.dart file. As you may see, it's a simple entry point for the application with material app and diary page there. The diary page itself is a stateful widget. Its state has three fields: diary entries, which is a list of records with text and sentiment scores that you may see here on the screen, a classifier, which is a helper for our model, and just a loading flag. By default, the loading is true and it will be set to false once classifier will initialize the model. Here, the screen itself is rather simple. We have scaffold and list view builder that just shows the list tiles here, and a button that shows the alert dialog, prompts the user about how was their day, and then close this dialog, classify the message, calculates the sentiment score, and adds it to the list of diaries. Of course, the most interesting part is the classifier itself. So here it stores constants for model and vocabulary files. And by the way, if you want to experiment yourself, you may download the same model with this URL. Machine learning is all about matrix multiplication. That means that the input lengths should always stay the same. And in this case, it will be 256, which means our classifier will calculate the sentiment score based on first 256 words. Let's look at the classifier itself. It has some sort of initialization, which is common for ML models. There most likely will always be two functions. The first one will prepare the interpreter, which is a special class that allows you to communicate with your machine learning model. And there might be some sort of specific for your particular model. In that case, we have some helper functions that populates the dictionary, which is a map of string and integer from the vocabulary file that I just showed you. And now let me show you how classification actually works. As I said, machine learning is all about matrix multiplication. That's why we need to convert strings into numbers first, and that's what we do with tokenization. You may see that we split the user entry, and for each word in that user entry, we are trying to find the number in the vocabulary. If the word is in dictionary, we return that number. Otherwise, we'll return a special number for unknown words. Then we populate the input, prepare the output, and run the interpreter and get in the result. You may wonder what's the format of the output, and for each model it's different. In this particular case, the second output value shows how positive the sentiment is. Another classical example of machine learning used directly on device is object detection. Once I worked on a retail application for supermarkets. It was not really for consumers, but for special staff personnel who used an app with object detection functionality to identify what was available on shelves in supermarkets. Of course, the model that was used there was a state-of-the-art proprietary model, but we may build something similar with a free mobile net model. Let me show you the application first. Here we have a single button that opens the gallery, and let me pick some image from it, like for example this one. All right, seems like on this photo there are two persons. Or this one. While my cat tried to hide, the ML model still identified him as a cat. Or this one, that's a bear. Well, close enough. Or this one, still a cat. Okay, let me show you how it's done. Here we have the same TensorFlow Lite or Lite-RT dependency and two dependencies that allows me to work with images. We have assets folder with the model itself and a map of labels the model can identify. Let me show you the implementation. The same entry point of the app with a single detection page, which is a stateful page, stateful widget with detector and image picker and the image itself. Same initialization as in our previous application, and same floating action button that asks image picker to provide an image from the gallery and then analyzes it with the machine learning. Let's look at the implementation of object detection now. As you may see, the implementation looks really similar to what we had in our first demo. And by the way, here is the link for the model itself. It still has an interpreter and some labels, which in this case is a list of strings now. We load the model and initialize the interpreter. We load labels, just like in our previous demo. And then we have some boilerplate code that we need to do. Like, for example, we need to create a list of integers from the image. That's why we decode the image, we resize it for the format that our ML model understands. And then we ask the model to provide the output. And here you may see the boilerplate that actually draws rectangles and labels on the image. As you may see, this application has much more boilerplate code, but it's not that complex. I will upload it on my GitHub so that you can play around with it yourself. And that's one of my favorite applications and the one that I'm actually very proud of. Overall, I really love the healthcare domain, and once I worked on an application that tracked physical activities for elderly patients of a hospital. We used machine learning for pose estimations to track whether users use the application and are doing exercises. and to give them hints on how to do exercises properly. I propose to build an application with the PostNet MobileNet model. You may say, oh, but both ARKit and ARCore already provide a possibility to estimate pulses. So why would I want to use some other models? And the answer is that, well, you actually have much more control over the custom models. Let's build the app now. As usual, let me show you the application first. Here is an app running on my iPhone. So let me run this video. And as you may see, the application tries to estimate the pulse of this lady here. So that's how the app works. I used the best 25 minutes exercise routine video for seniors over 60s here. And let me show you how the application works under the hood. So here it has the same entry point. Speaking of the dependencies, LiteRT and image and camera dependencies now. Pulse page is a sample that I shamelessly took from TensorFlow examples here. You may see that it's really similar to what we had before, but it has even more boilerplate because now we need to deal with the camera, we need to initialize it, start streaming. There are tons of helper functions that describes key points of bodies, body parts, person array, tons of helpers that allows us to works with isolates there. Some image utilities that again are required to convert image data between different formats. And of course the page itself that actually combines all that functionality under the same umbrella. You may see things become a bit more complex now. So I showed you 3 examples, and probably you noticed that it's not that easy to use machine learning in mobile applications. Is there a simpler way for us, regular mobile developers, to actually use ML in our apps? And the answer is definitely yes. You may try MediaPipe, which is a framework that uses LiteRT under the hood. It's a Google project too, and it's also cross-platform. It's supported on Android, web, iOS, and Python. However, the Flutter port is not quite yet production ready. Unfortunately, we cannot use it with the latest stable version of Flutter. But don't worry, you may use any mobile SDK in Flutter apps via plugins. Let me show you how you can easily create a wrapper for MediaPipe text capabilities and leverage the BERT model for much better sentiment analysis. Let's rewrite our diary application. Let me show you one more implementation of the sentiment diary. Let's add a new diary entry here. Something like, again, today was a superb day. I was in a park with my friends, and then we had a party. And now you may see that the sentiment is definitely positive, which is far more accurate because, yep, this message looks like a positive one to me. One more entry. Today was the worst day possible. I don't want to talk about it. And now you may see that it's super negative, which again feels right. And the last entry is today was okay. Now it's positive again. I think we might want to fine-tune this model a bit. Let me show you how it's built now. As I said, MediaPipe has no yet production-ready plugin for Flutter. That's why I needed to create an on-device AI text wrapper. Let me show you dependencies first. It has plugin platform interface and pigeon dependency that would allow me to generate bindings for iOS SDK. For iOS SDK, I needed to specify a dependency. Here it's MediaPipe tasks text. And in pigeons, I created or specified the API for my plugin. Some pigeon boilerplate, like I needed to define the API and some models that I want to be visible in my plugin. Here is the library itself, text classifier. That would be the class that I can use from my example for MediaPipe. Here, the main entry point and diary page stays almost the same, and the only difference is that now we don't need to initialize the model first, because I implemented it in a way that it will kind of initialize itself when we'll try to classify the text, and that's the whole classification logic. As you may see, it's so much simpler now. We've covered many use cases now, but you still might be wondering, hey, but can I actually run LLMs locally? And the answer is yes, of course you can. LLM is still just a model. You may easily use it via MediaPipe framework, or you may use Flutter Gamma package from PubDev if you are interested in the Gamma model. Should you run AI on device? Well, local AI is much harder to build. You may see that most of the time it requires some deep understanding of what is actually going on under the hood. And it's not easy to train a model from scratch or even fine-tune an existing one. But here is a pro tip. You could use cloud big LLMs to help you first find and then fine-tune local models. Use AI to help you build AI. Because in the end, it's all about the user. If local AI delivers a better experience, it's worth the effort. And that's all from me today. Let me know if you'd like a deeper talk about local AI. Follow me on social media, and I hope to see you at my next talk. Thank you.